So one of the first things you're going to need to learn for the BC test is how to find the length of the line of a function between 2 points. So for example, if we have function f of x that looks like this when graphed out, we want to find the length from tracing along the curve between x equals a and x equals b. Now we can't simply measure a curve, but we can approximate it by drawing straight lines that we can measure. This is essentially just like finding the area under the curve of a line, because the more straight lines we add, the more accurate our answer becomes. So in order to have the correct answer, we need to use an infinite amount of infinitesimally small lines. And so we know we need to use an integral. Now for the area under the curve, as you'll recall, one interval looks like this, with the change in x as the base of the rectangle, and the value of the function as the height. To find the area, you just multiply the two together and put it in the integral expression. When the smallest interval of our integral for finding the arc length, we're dealing with the change in x and the change in y, which creates a right triangle whose hypotenuse creates our approximation of the length. So we just apply Pythagorean theorem, dx squared plus dy squared, square root of the sum, and you get the length. And so in order to make this fit into an integral, we need to be in terms of x. So we need to somehow get a dx out of this square root. Well, not to fear, we can simply factor out the dx squared from this expression, and then it can jump out of the square root and become the dx that we need to make this an integral. Add the limits of integration on the curve and we can solve. And now we have dy dx in the expression, which we can rewrite as f prime of x, the derivative of f of x, and we have an equation that we can work with. This is the equation that you'll need to memorize to answer certain questions on the AP test. Hopefully the steps that I showed you in order to derive it will help make that easier, since at first glance it seems non-obvious. So now that we know this formula, let's test it out. Let's find the distance of the curve of e to the power of x from x equals -1 to x equals 2. So we have a formula that we know will always work, and we can just start by inserting the limits of integration -1 and 2. We just need to find the derivative of f of x, which in this case is easy. The derivative of e to the x is e to the x. Now remember, we have to square that function before we evaluate the integral. That's an easy step to get tripped up on. So now, since this is a pretty ugly expression where integrals are concerned, we'll just have to evaluate it using our calculator. That's a pretty straightforward procedure. Just make sure that you're careful to copy in the correct details. And we should get, for the distance of this curve of our graph, 7.981, rounded to 3 places, as is required for the AP test. So that is arc length, plain and simple. If you just practice doing this with several different types of functions, polynomial, trigonometric, rational, and maybe a couple others, you should be able to get the hang of it. In our next video, we're going to be learning about how sum integration is improper.